Hey Techno Studs, let's get into network address translation. Most of our networks nowadays use some sort of network address translation, so let's get into what it is and how we would use this. We're going to start out with this video talking about network address translation terminology. To understand the terminology is actually pretty important to passing the Cisco exam. So we're going to start out by talking about that. Then we're going to get into what a NAT table is. We'll get into some other benefits behind NAT, and then we'll wrap things up by talking about the disadvantages. In this video, we're going to start out by talking about network address translation terminology. So we'll start out by talking about some of the terminology, and if you're taking the exam, then that's going to be important to understand. So don't pass that one up. Then we're going to get into the NAT table and what the NAT table looks like. We're going to get into some other benefits with NAT besides just saving on public address space. And then we're going to finish up by talking about some of the disadvantages around NAT. As I mentioned, it's important to understand some of the terminology when it comes to the CCNA exam. So first of all, you need to understand the difference between public and private, and we talked about that in our last video. When we're talking about public and private, we're really talking about blocks of addresses or ranges of addresses, and it's defined by RFC 1918. So a public address would just be those addresses we find in the outside world, the block of addresses that are routable on the internet. Versus a private address would be just those addresses that are only found, the blocks of addresses that are only found internally. It's defined by 1918, found internally. But Cisco further defines what is the difference between local and global and inside and outside. Now, what we could do is we could just refer to a source, such as this laptop right here, and a destination, which would be maybe like a web server that's out here. So let's say this is a web server. Now the problem with using source and destination is as we go through this router 2, that this goes to this destination, but then information comes back, and this becomes the source, and this becomes the destination. So using source and destination doesn't quite work for us. So what we need to do is we need to come up with different terminology, which is why Cisco did this. So this is called the inside, and this is called the outside. And then therefore, it doesn't change. The outside is always referring to this machine right here, and the inside is always referring to this machine right here. But we have another problem, and that is that this is a packet that's being sent, and it's got an IP header on here. And that IP header changes when it goes to the outside, all right? So what we actually needed to do is define what information we find in this, what IP addresses we find in this IP header on the local versus the IP headers that we find on the global. So that's where local and global come in. So local is any of the IPs that we find in the IP headers that are inside your network. Global is all those IPs of the IP headers that you would find in the rest of the world. And inside is from the laptop or whatever is making this request and going to, or inside your network, which is going to the outside machine that is outside of your network. So that is what the difference is. Let's go through that one more time with just a little different aspect, a little different look at this. This machine right here, this demo laptop, is trying to reach a web server right here. It's sending out a packet, and so this is the packet that's being sent out, and it gets translated, and this is the packet that it gets translated to. So if we were to take a look at it, it has a source IP address and a destination IP address, and that gets changed to a different source and a different destination. So what do we call this? When it is local, we can see that it says local right here. meaning it's on the local network, and the source is the inside computer, and the destination is the outside web server. So inside local, outside local, and then that gets translated to inside global and outside global. And that's the outside global is the destination and inside global is the source. So what's interesting about this is this demo laptop is reaching out to a web server that's out there. And that web server, hopefully, is going to reply and send that web page back to that demo laptop. And so this router needs to keep track of that translation because it's translating from some sort of inside local to it inside global as it goes out to the rest of the world. And so what it does is it keeps track of that using a NAT table, network address translation table. And what it does is as it's heading out, it records the machine and the IP address that it's using. So in this case right here, it's translating from 10.1.10.34 to 184.191.63.4. So that's translating from the inside local to the inside global address. RFC 1918 was really a way to be able to stretch IP version 4. We're running out of public addresses, and what this does is it allows us that even though we have a lot of different IP addresses within our network, to only need a few public addresses on the outside world to facilitate this communication. So that's why it was created. But there are several other benefits to this as well. As an example is this demo laptop, or let's say this demo Pi right here, only has this NATing table that's set up if it's reaching to the outside world. It limits the exposure. If this doesn't have a public address, then there is no way that a machine can directly connect to this demo Pi right here, making it more secure. So NAT can be a way of implementing security, although really what we need is a true firewall on the outside, but NAT does have a certain amount of security that's involved with it. Another reason why, or another benefit to this, is it provides consistency within our network right here. And what I mean by that is I've given this a 10.1.0.0 range and said anything in the second octet, if it's 1, represents my local network right here of this site. Anything that's 10.240 represents that the network connections or the links between these different routers. Anything that's a 10.2 represents this site over here. The third octet represents then the different networks that are at each one of those sites. I have lots of addresses that I can work with. So the fact that I chose this 10 range, I can say that each octet represents something different within this. Gives me a lot of flexibility and I don't need to worry about wasting addresses. And so I'm really able to create consistency with how I'm using my IP addresses, and they all make sense within my network. So that's another advantage to this versus if I have public addresses and I've had networks that have ran off of public network addresses out, and you have to be really conservative with how you use those public addresses. You can't just be using them for just any devices. You got to be very selective in how you break that apart and use that. All right, the other way that this is really beneficial too is if you change an internet service provider. If these were all public addresses, then it could cause a problem if you switch internet service providers and now have a different set of IP addresses that you have to dole out, to hand out to all these different devices. I have to go and change all of this networking and redesign all of the networking just because I want to go with a different provider. Whereas if I have this private addressing here, it's just a matter of, okay, I'm just going to connect to another device. Failover is another thing too, is if I have multiple providers for failover purposes, so I can have redundancy within my network, this makes it a lot easier. So there's quite a few advantages to having it set up with private addressing. There are, however, several disadvantages to network address translation. So what are some of those disadvantages? Well, first of all, this is an extra function that this router has to do. It creates another delay point of getting your traffic from one point to the next. Another disadvantage to this is you have a loss of end-to-end connectivity or end-to-end traceability. You know, there are still some tracing that we can do throughout this network, but we do have, because we're translating, we can't as easily see what's happening on our network and figure out what's going on. So we lose a little bit of being able to visually see what's happening within our networks. Another thing that it can complicate is things like tunneling protocols. What we'll do is at some point in time, we'll talk more about tunneling protocols, which is tunneling to maybe some sort of other site that we have. And what happens when it gets translated? Does it get translated before the tunnel or right after it gets into the tunnel? And do we want it to be translated? Do we not want it to be translated? So there's questions with that. It complicates some of our tunneling protocols such as VPNs. It also complicates outside traffic that's trying to get to maybe one of our web servers. If there's some sort of device that wants to get to our web server and this has a private address to it, we're going to have to do some reverse translation with that, so that can complicate that a little bit. I will say though that as we're troubleshooting these issues, it's more common to have private addresses on your network than having public addresses. So even though it complicates things a little bit, there's a lot more information out there when it comes to this translation, and there's almost, when you're doing research, it's almost assumed that you are translating. And so troubleshooting guidance that's out there or how to set things up actually just assumes that you are doing some sort of network translation, and it can be complicated trying to translate that document or get the pieces of in the document out if you're using public addresses on your network. And I've experienced that firsthand when I've had networks that use public addresses. One other thing that I'll add to this disadvantage list is you do have to be careful about your address range and making sure it doesn't overlap with another address range if you're connecting into another network. And so what I mean by that is that let's say you have remote employees that are connecting into your network. If they were to have something that would be from the 10.1.0.0 range that's running on their home network, that could create some issues as they're trying to connect to resources in this 10.1.0.0 network. Their computers are going to see that as being a local network and take precedence, will start routing traffic to its own network rather than the network that it's supposed to be. So one other thing that you need to be careful about is because there are private addressing that can overlap with other private addresses, if you connect those networks together and they're overlapping, that could be problematic as well. This is one of the reasons why my home networks usually are not the default. What I mean by that is that you won't get onto my network and see a 192.168.0.0 network, because there's times when I'm VPNing in or remoting into other networks, and that is a common network range. And so my home networks, I choose a different range for my home network so I can VPN and connect into these other networks and not have an issue. So there you have it. We talked about some of the terminology, which you'll probably see on the test. We talked about the network address translation table, the thing that keeps track of what's getting translated, so when that traffic comes back, it can get translated back into your local network. Then we talked about some of the other benefits to network address translation, things like security and things like being able to change your network diagram and be able to really map things out because you have a bunch of addresses that you can use. And then we also talked about some of the disadvantages, things like tunneling protocols that makes more complicated, or how do you get traffic back into your network that can be a little more complicated as well. So network address translation's really cool, and there's some advantages and disadvantages, and we're gonna get more in depth into network address translation throughout the rest of this module.